Okay, let us now solve the next question from the practice sheet, that is question number 30. Question number 30 says, a tent is in the shape of a cylinder surmounted by a conical top. If the height and the diameter of the cylinder part are 2.1 meters and 4 meters respectively, and the slant height of the top is 2.8 meters. Find the area of the canvas used for making the tent. Also, find the cost of canvas of the tent at the rate of rupees 500 per meter square. Note that the base of the tent will not be covered in the canvas. Okay. So, let us understand this question line by line. It first says that there is a tent which is in cylindrical shape. Okay. So, you might have seen the circus tent, it is in cylindrical shape. Okay. It is a round tent. So, and at the top of that tent there is a conical top. Okay. The top of the tent is conical. So, just try to imagine the tent in a circus that is cylindrical in shape, its walls looks like in cylinder, and you might have seen the top of that tent is a conical figure. So, it says for this particular tent the height and the diameter of the cylindrical part. Okay. So, what it says is, let us try to draw the diagram. The tent is something like this. Okay, this is the circus tent, and at the top of this tent there is a conical figure like this. Okay, so what we can see is this part is cylinder and this part is a cone. Further, it says that the diameter and the height. So, height of the cylinder is given as 2.1. So, this is the height of the cylindrical tent. This is height which is 2.1 meters, and the diameter is 4 meters. Okay. So, diameter is 4 meters, it means this diameter, it is 4 meters like this. Okay. This is the diameter of this circle. Okay, this is a circular cylinder. Now, if 4 centimeter is the diameter, I can say the radius is 2 meters. So, the radius of the tent is given. Now, since it says that this tent, this cylindrical tent is surmounted by a conical top, then I can deduce that if the base diameter of this conical top is not given, I can very easily assume that definitely the base of this conical tent and this cylinder are same. Okay. It is not like that cylinder has a different radius and the cone has a different radius. Okay. The radii of both cone and cylinder are same. You can assume this because it is not given in the question that whether this conical top has some other radius or not. It simply says that this cylinder is surmounted by this cone. Okay. So, I can assume that both of them has the same base, that is same base means same base area, or I can say the diameter of this conical top is also 4 meters. Okay. So, now further it says the slant height of the top is 2.8 meters. So, what is the slant height of this top? I can see this length represents the slant height, it is 2.8 meters. Okay, this is the 2.8 meters. Now, it is given. Further, it says find the area of the canvas used for making the tent. So, it says find the area of the canvas. Now, what is area of the canvas? Area of the canvas means the area, the portion of this tent which is used, okay, in which the canvas is used to make this tent. So, how this tent is made? I can very easily see that the walls of this tent, okay, the walls of this tent are made of canvas. So, definitely this area, the making of this area includes the canvas, so definitely the canvas is used for making this particular walls, okay, the lateral area. So I will say that the lateral surface area of this cylinder or the curved surface area of this cylinder is made up of canvas. So if it is asking area or the exact word, okay, it says the area. So area of canvas, it includes first thing, that is the canvas is used to make the walls of this cylinder, okay. So definitely the area of these walls is included in the area of canvas. So what I can say is area of canvas is consisting of two values. The first one is curved surface area of cylinder. This is to be included. Now should I include the base of the cylinder? Is the base containing the canvas? क्या इस बेस में कैनवास लगा है? नो, डेफिनेटली नॉट. बेस तो ओपन है. अगर हम सिर्फ टेंट के सिलेंडर को देखते हैं तो सिलेंडर का टॉप और बॉटम दोनों ही ओपन है. क्या हमने यहां पर कैनवास यूज किया है? नहीं, हमने यहां पर किसी प्रकार का कोई कैनवास यूज नहीं किया. दैट इज सिलेंडर का टॉप भी ओपन है. सो डेफिनेटली अगर मुझे एरिया ऑफ कैनवास निकालना है, सो आई विल इंक्लूड ओनली द वॉल्स ऑफ दिस cylinder, okay, because only the walls are made up of canvas, not the base, not the top. Now second thing, the same canvas is also used to make the top of this complete figure, complete solid figure, and I can see the top is basically a conical surface. So try to understand, if I am talking about this cone, then how much area of this cone is used, okay, is made up of canvas. I can see the base of the cone is not covered. This base of this cone or the top of this cylinder is not covered. सिलेंडर का टॉप ओपन है और कोन का बेस ओपन है, ओके, बिकॉज ये दोनों जुड़े हुए हैं. देन कौन सा एरिया इंक्लूड होगा कैनवास के एरिया में? आई कैन सी कि इधर जो एरिया है, दिस एरिया, दिस पर्टिकुलर एरिया इज मेड अप ऑफ कैनवास. सो डेफिनेटली अगर हम एक कॉनिकल सरफेस के इस एरिया की बात कर रहे हैं, सो विच इज दिस एरिया? दिस एरिया इज द लेटरल सरफेस एरिया, ओके, और द कर्व्ड सरफेस एरिया. सो आई विल से एरिया ऑफ कैनवास मतलब कर्व सरफेस एरिया ऑफ सिलेंडर प्लस कर्व सरफेस एरिया ऑफ कोन. बिकॉज सिर्फ कर्व सरफेस एरिया सिलेंडर का जो है दैट इज मेड अप ऑफ कैनवास एंड द कर्व सरफेस एरिया ऑफ कोन इज ऑल्सो मेड अप ऑफ कैनवास, और कहीं पर भी कैनवास नहीं लगाया गया. सो एरिया ऑफ कैनवास, नाउ आई कैन कैलकुलेट इट वेरी इजीली. आई कैन सी व्हाट इज द कर्व सरफेस एरिया ऑफ सिलेंडर. द कर्व सरफेस एरिया ऑफ सिलेंडर इज 2 pi r h, okay, plus curve surface area of cone. What is the curve surface area of cone? It is pi r l. L means the slant height. So now I can substitute the values. It will be equals to 2 times pi. Now radius of this cylinder, I can see diameter is 4, radius is 2. So the radius is 2 into height is 2.1. It is given, okay. This height 2.1. Now plus pi into r, curve surface area of this cone. R is radius which is 2 again, because जैसा हमने कहा base of this cone and the top of this cylinder are similar, okay, वो दोनों exactly similar है. That's why the radius of the cone will also be 2 meters. And then L means the slant height. Now slant height is given as 2.8 meters. So plus pi into 2 into 2.8. Okay, so let us solve this. This will be 2 2s are 4 and 4 into 2.1 is 8.4 pi, plus this will be 2 into 2.8, that will give you 5.6 pi, okay. So I will calculate the area in terms of pi only. How? This is 8.4, add 0.6 from this 5.6 to this 8.4. So 8.4 plus 0.6 is 9. 9 plus 5, so 9 plus 1 is 10 and 10 plus 4 is 14, okay. So mentally you can calculate in this way and you will get 14 pi, and the unit of this tent the unit of measurement is meters, so this will be in meter square. So 14 pi meter square is the curved surface area of this solid figure, or it is the area where the canvas is used, or the area of canvas. Now, so this much area of canvas is used to make this particular tent. Now, further it says, find the cost of the canvas of the tent at the rate of 500 rupees per meter square. It means if I want to purchase 1 meter square of canvas, that is area of 1 meter square, that is 1 meter by 1 meter in length and breadth, then that canvas will come for 500 rupees. So I will say rate of canvases, rate of canvases 500 rupees per meter square. So it means for 1 meter square canvas I need to pay rupees 500. So if I want to have 14 pi meter square canvas, then how much I need to pay? Just multiply this 14 pi into 500. So this will give you rupees 500 into 14 pi. Okay, this much amount of rupees you need to pay to get this tent ready. Okay, so this much canvas you need to have. So you can see this question is a practical situation. It's simply that there is a tent, I need to set up a tent, and I saw that the canvas is at the rate of 500 rupees per meter square. So how much canvas will be used to make my tent? Okay, it is like this. So this is the solution for question number 30. A very good question. Okay, you might get confused when you need to calculate the area of canvas. Okay, try to understand this concept. Area of canvas means those areas where the canvas is used. So I can see the walls of this cylinder are made up of canvas, so I counted that walls. Okay, then the top of this tent is also used to is also made up of canvas, so I counted the curved surface area of cone. Not the base of the cone, not the base of the cylinder, not the top of the cylinder, because they are not made up of canvas, because this is open. In between the cone and the cylinder, this is the open surface. Okay, so this much amount of rupees I need to pay to have this tent. So this is the solution for 30th question. Okay, you note this, then we will continue. Okay, let us now solve 31st question from the practice sheet. It says a wooden toy rocket is in the shape of a cone mounted on a cylinder as shown in the figure. The height of the entire rocket is 26 centimeters, while the height of the conical part is 6 centimeters. The base of the conical portion has a diameter of 5 centimeters. Okay, that is the base of the conical portion, while the base diameter of the cylindrical portion is 3 centimeters. If the conical portion is to be painted orange and the cylindrical portion yellow, find the area of the rocket painted with each of these colors. Okay, so what it says is that for this rocket, for this toy rocket, let us draw the diagram for this toy rocket first. The diagram is something like this. This is the conical top of this rocket, and we have a cylindrical base of this rocket. So here it says that total length of this rocket, if I talk about the total length, then total length will be calculated from top of this cone till the base of this cylinder, and this total length is given as 26 centimeters. Okay. Further, the height of the cone, height of this conical part is given as 6 centimeters. So this is the conical part. So this is 6 centimeters. So now I have the conical part as 6 centimeter, the total length is 26 centimeter. So what is the length of this cylindrical portion? The length of this cylindrical portion will be 26 minus 6, that is 20 centimeters. Okay. So we have deduced this length. Now further it says the base of the conical portion has a diameter of 5 centimeters. So the diameter of this conical portion is of 5 centimeters. So let us mark this diameter. This is the diameter as 5 centimeters. So if diameter is 5, then what is the radius? Radius is half of this. So this is the radius, that is 2.5 centimeters. So we have the radius of the conical surface. Now after that it says the diameter of the cylindrical portion. So this is the cylindrical portion and its diameter is this one, which is 3 centimeters. This is the diameter. Now if I have the diameter, then what is the radius? This is the radius, which is 1.5 centimeters. Okay. So I have the radius, I have the diameter, I have the height of the cylinder, I have the height of the cone and its diameter. Now so we have deduced the diagram completely. Further it says, if the conical portion is to be painted orange, that is this conical portion, I want to paint this conical portion with orange color. Now what is the part of conical portion that I can paint? Okay, first let us try to understand this concept. I can see if I try to paint this conical surface, then this conical figure, then I can see its lateral surface will be painted, this surface. Okay, this complete surface, this lateral surface will be painted. Then this is the conical shape, this is the conical figure. So I have painted the lateral surface of this conical shape. Now what about its base? Can I paint the complete base of this cylinder, this cone? No, I cannot paint the complete base of this conical figure. Why? Because the base of cylinder is attached with the base of this conical surface. So the portion of conical base where the cylinder is attached will not be painted. I cannot paint that surface of this conical base which is attached to the cylinder. Okay. So what I try to say is, we cannot paint the complete base of cone because some portion of base is attached to the cylinder. Now since some portion of this base is attached to the cylinder, so I can only paint the rest of the surface, okay, that is open to atmosphere. Try to imagine this rocket in your mind and try to think which portion of this conical top is open to atmosphere, it's open to surrounding. I can see the complete lateral surface of this conical top is open to surrounding, but in the base only some portion, only that portion which is not covered by this cylinder is open. So I can see that only this portion is open for coloring, open to surrounding, this portion. Now can I deduce the area of this portion? Because I want to deduce the area, the portion of this cylinder, this cone where I can paint. So for painting I need area, not the volume, because paint can happen only on area, it cannot happen on the volume. So now my task is ultimately to determine the area of this conical top which can be painted. So I will say area of conical top open for paint includes, the area of conical top which is open for paint includes area or lateral surface area or curved surface area plus area of base which is open, okay, which is open to atmosphere. So now what is the curved surface area of this conical top? The curved surface area of a cone is pi RL, that is pi into radius into slant height. But do I have the slant height? No, then definitely I need to calculate the slant height. How to calculate the slant height? For this conical surface, I can see this is the height, okay, and this is the radius. So this is the height which is 6 centimeter and the radius is 2.5. So this slant height or L, this line, this length L will be equals to, now where should I write L? L I can write here. So L or the lateral slant height of this conical top will be equals to square root of 6 square plus 2.5 square. Now why 6 square plus 2.5 square? You can see this is a right angle triangle. I can apply Pythagoras theorem. This is the hypotenuse, this is the perpendicular, and this is the base or the radius, okay, this radius. So L square will be equals to square of this perpendicular plus square of this base. So that's why it is square of perpendicular which is 6 centimeter and the square of base which is 2.5. So this is the lateral or the slant height, okay. So the curved surface area of this conical top is equal to pi into radius is 2.5 into slant height. In place of slant height I will write 36 plus 6.25, square of 6 and then square of 2.5, 36 plus 6.25, okay. Now plus the area of base which is open to the atmosphere. Now how much area of the base is open to atmosphere? If I see that complete area of base includes this portion, okay, and from this portion what I did is I subtracted the area where the base of this cylinder is attached. So how much area of this conical base will be covered by the cylinder? The area of the base which is covered by the cylinder will be equal to area of this conical of this cylindrical base, okay, means this circle, this much circle, this white colored circle area will be covered. So let us mark it like this, this white color circle area will be covered. So I need to subtract this area from the complete area of this base. So the complete area of this base is pi into 2.5 square, this is the area of the base of this conical surface, minus I need to subtract this area. Now what is this area? This area is the area of top of this cylinder which is pi into 1.5 square, because this is also circular. So pi r square is the area of circle, so minus I will subtract 1.5 square, okay. So this will be the area in centimeter square. This is the area of the conical top which can be painted. I can paint only this area, okay. I cannot paint any other area of this conical top. I cannot paint the area which is covered by the cylinder, okay. So we have calculated the area of conical top. Now further it says, so if the conical portion is to be painted orange and the cylindrical portion is to be painted yellow, find the area of the rocket painted with each of these colors. So it clearly says that conical top has to be painted with orange color. So how much area can be painted with orange color? This area, this is the area that can be painted with orange color, okay. So this also known as area to be painted with orange color, okay. Now the second thing I need to calculate is the area that need to be painted with yellow color. So what is the area to be painted with yellow color? Area to be painted with yellow color is basically area of cylinder which is open to atmosphere or to the surrounding, which is open to surrounding. Now what should be the area of this cylinder which is open to surrounding? I can see that this walls of this cylinder, that is the lateral surface area of this cylinder, is open to surrounding. So definitely this area will include curved surface area of cylinder. And what is the area left? I can see this is a toy, so the base of this cylinder is also available. I need to paint the base also, and base is a circular base. Now can I paint the top of this cylinder? No, I cannot paint this top of this cylinder. Why? Because this is attached to the conical surface. So this area is not open for paint. Okay, it is not open to atmosphere. Only this base area plus this curved surface area is open to atmosphere. So area that need to be painted yellow will include the curved surface area of cylinder plus area of base of cylinder. This much area is available for paint. Now what should be this area? This is equals to curved surface area of cylinder is 2 pi RH. So 2 into pi into r. What is the radius? Radius 2.5? No. Radius is 1.5. This is a thinner cylinder compared to the conical surface. So 1.5 is the radius and the height of this cylinder is 20 centimeters. So curved surface area will be 2 into pi into radius is 1.5 into 20, that is the height, plus area of base. This is the base. This top will not be included. Only base will be included. So the base area will be pi r square and radius is 1.5. So this will be pi into 1.5 square. So this much is the area in centimeter square that need to be painted with yellow color, or that is the area of the cylinder that is open to atmosphere. Okay. So what you can see in this question, it's a bit tricky question, a logical question, that how to include the areas and how to exclude the areas. I can very clearly see that when I join two different solid figures, some of their part gets hide. Okay, कुछ part उनका hide हो जाता है. That's why यहाँ पर जैसा हमने देखा इस सिलेंडर और इस कोन का, इनका बेस हाइड हो गया, बट क्योंकि कोन, बट दिस कोन, इस कोन का डायामीटर ज्यादा था, दैट्स वाई इस कोन का पूरा बेस एरिया हाइड नहीं होता, कुछ पार्ट हाइड होता है और इतना पार्ट बच जाता है. सो दिस ऑल्सो बी पेंटेड विथ ऑरेंज कलर. ओके, दैट्स वाई here we have applied this logic. Okay, so just solve this value, solve this equation, and you will get the value of area that need to be painted with orange, and from here you will get the yellow. Okay, so this is the question number 31. Very interesting question, very logical question. You need to be very careful while solving this question. Okay, so first you note this, then we will continue.